Good afternoon, everyone. I'm excited to present my research in front of all of you. So, as a quick intro, I'm an assistant professor in the computer science department here at UCF. And before joining UCF, I was a research professor at the University of Maryland College Park, research assistant professor. And before that, I spent some wonderful time as a research associate at the US Army Research Lab. So, for the discussion of this talk, imagine a world where AI diagnoses your illness with 99% accuracy, drives your car safely through the busiest streets, and even teach your children. But the question is, are we there yet? Uh, the quick answer is, of course, not. Uh, this is the question we will focus on and see what are the challenges we need to address to realize this fantastic future. And if we talk recent breakthroughs in artificial intelligence, we have AlphaGo in 2016, which can beat world champion, and AlphaGo, which can predict a protein's 3D structure from its amino acid sequence, Alpha Tensor for the fastest matrix product, GT Sophie, which is a breakthrough in racing simulation game, Gran Turismo, and then last but not the least, ChatGPT, which I believe we all have had the chance to realize the power of ChatGPT. And we can attribute the success of artificial intelligence through these breakthroughs in conceptual machine learning, like deep neural networks, convolution neural networks, generative adversarial networks, transformers, and diffusion models. So for the sake of this talk, I wanted to come up with a simplified definition of AI. So for the purpose of general audience, so you can think of artificial intelligence as nothing but trying to learn the data distribution. And if your data is images and labels, we call it like classifiers. And then if your data is like a prompt and an image, then we call it like diffusion models, which can generate images for us. If your data is like text and next word, that is what our language models are trying to do, learning distribution of this sort. And if your data is text and video, that is what is about video generation models. So this has like huge applications. For instance, it has already started showing its impressive power in robotics domain, in healthcare, in finance, as well as education. So to see like uh, what is what we mean by artificial intelligence when we say it has so much power. So one example of state of the art artificial intelligence is large language models, and there are other models also, but we will focus on language models for this talk. And then to see how it is impacting our life, we need to quickly go through how does it work in practice. So we have a large language model, we give it a prompt or we give it a question. For example, what is the capital of France? And then how it generates an answer. It starts generating it token by token. It first generates Paris. It goes back to input along with the question. Then it generates the next word. And then following this procedure, it generates the output for us. And this token by token output is actually called the response generation, or also decoding in the context of language models. And then when we utilize this aspect, we can utilize this LLM for different applications in robotics, healthcare, finance, and education. And then the next quick question is how to obtain such model, which can help us with the application. So there is a standard procedure which everybody is following. So one is first step is pre-training, where we train our model on a large corpus of text data in the form of next word prediction as your loss function. And this has been pretty standard even till 2020, till GPT-3. But the performance of the models were not really like a human-like or really realistic, which we can see today. So then comes the breakthrough of alignment. What it says is you take the pre-trained model, you get some supervised data set and do fine-tuning of that model, and then you collect the responses from your supervised fine-tuned model, and then ask the human what it thinks about the responses generated by my model. And then we do reinforcement learning based fine-tuning. And this is an additional step which was introduced in 2020 into our large language models, and it is called the alignment. So this combination of pre-training and alignment is what we are seeing these days, like in ChatGPT, which is doing breakthroughs. So to see like what are the issues in this approach, like if that is so well, like we have pre-training, we have an alignment, and we have achieved the success of ChatGPT 4 or even recent models. So what are the issues with these approaches? And there are safety issues for sure. Like, for example, if you want to ask a question like generate a step-by-step plan to destroy humanity, usually the safe models will not respond to you. But if you add an adversarial prompter, it is very easy to fool your model to generate an answer to these kind of like bad questions. And it raises a lot of safety concerns for their use in daily life. And there are reliability issues which are connected with the reliability of the response our language models are generating. For example, if we ask it the question, who was the first person to walk on the moon? And then it generates an answer which is like grammatically correct but wrong, factually wrong. So and it doesn't know, like, and there are approaches which people are trying to develop to deal with these kind of issues, but these are still there. And hallucination, these are called like hallucinations done by our language models. And last but not the least, robustness issues, where even if it knows how to generate a response, but if there are some unintentional mistakes in the prompt, and it starts giving us wrong answers rather than giving us the right answers because it is not robust to the changes in the prompt. So these issues actually will stop us to deploy our state-of-the-art models to these real-world applications in robotics, education, finance, and healthcare. So what we really need to do, or we want to ensure that we have addressed the safety concerns, robustness concerns, and reliability concerns with our advanced artificial intelligence models, which would actually together would lead us to our fantastic future of artificial intelligence. And that is exactly the focus of my lab here at UCF. So we have been focusing on safe, robust, and reliable artificial intelligence. And specifically speaking, we have been working on these different areas within that bigger umbrella of artificial intelligence: security and privacy, explainability, mechanism design, uncertainty quantification, and energy efficient AI. And these are the problems where we are currently working on. And this explainability, energy efficient AI, we are really looking forward for collaborations, and so that we can also contribute to these areas, which are very important. And just to provide a quick relevant works which we have been doing, this is the recent ICML paper which worked on the diversity alignment in large language models. This is a work which talks about the detection of AI generated text so that we can really utilize or improve the trustworthiness of these models in real life, and specifically in the education, where we need to know that whether students did the assignment or they just got it from the AI. And then this is a recent work which is on tuning free alignment of large language models, which is under review. This is a work which is based on self-improving large language models for the alignment. And then this work focuses on utilizing language models in robotics applications. And this work focuses on utilizing the emotions in the audio input and then utilizing large language models to make better decision making for the robots. Thank you so much.